Okay, so we're back with the third and final installment for section 9B. We're going to talk about how to actually perform the entire test, t-test for the slope. So a t-test for the slope is, this is a significance test of the null hypothesis that the slope beta of a population regression line is equal to a specified value, most commonly 0. So as always with a t-test or any type of hypothesis test, we're going to follow the four-step process for inference. So we have a new example here. So let me read through it and then we'll talk about how to perform the full test here. Child development researchers explored the relationship between the crying of 38 randomly selected infants when they were 4 to 10 days old and their scores on an aptitude test later in life. They thought that if infants who were more easily stimulated might cry more often as an infant, but also develop faster. A snap rubber band on the sole of the foot caused infants to cry. The researchers recorded the crying and measured its intensity by the number of peaks in the most active 20 seconds. Several years later, they recorded the aptitude score for each child. Here we have the data and computer output for the least squares regression analysis of the data. So we have our scatter plot here, our residual plot, our histogram, and the computer output. So we want to know, do these data provide convincing evidence at the 0.05 significance level of a positive linear relationship between cry count and later aptitude score in the population of infants? Now, just a note here, when in this case, the significance level 0.05 was stated. If a significance level is not given, you're going to assume to use 0.05. But if it is stated, go with whatever is stated. So the four-step process, state, plan, do, conclude. We're going to state what we're going to do. We want to test the null, where beta is equal to 0, and the alternative, where beta is greater than 0, where beta is the slope of the population regression line relating y equals aptitude score to x equals count of crying peaks in the population of infants, and use alpha significance level of 0.05. So we put the null and alternative hypothesis, defined the parameter in context of the problem and what it means, and stated our significance level. In the plan step, first thing we're going to do is state the procedure that we're going to then check the conditions for. So this is a t-test for the slope. Okay. We have the linear one requirements here for the conditions. So first, linear. If we look up at the scatter plot, it shows a linear relationship between cry count and aptitude score. And if we back that up with the residual plot, it shows a fairly random scatter about the line equals 0, y equals 0 residual line. Okay, so you're looking for a general linear pattern here and a general random scatter in the residual plot. And again, don't worry about small little details here. If it's a general type of pattern, you're okay for the linear. So for the normal, if we look at the histogram, it doesn't show any strong skewness or obvious outliers. I mean, you might have one here, but it's not necessarily going to be an outlier. If it was way up at like 240, then that might be considered an outlier. But again, in general, it doesn't have any strong skewness or obvious outliers. If we look at the equal SD condition, the residual plot shows a fairly equal amount of scatter around the horizontal line at 0 for all x values. So right here. And then for random, it says it was a random sample of 38 infants, and the 10% condition, since it was random selection, random sampling rather, 38 is less than 10% of all infants. Again, when you check the conditions, you have to spell it out like this. You can't just write each condition down and then put a check mark. In our do step, this is where we're going to calculate the t statistic and p-value and so forth. But let me back up a second. Because our cry count slope is 1.4929. This does give some evidence for the alternative hypothesis. Now, you don't have to put this in your significance test. You don't have to make this statement that I have right here with the star. I'm just showing you that already we have some evidence, but we don't know if it's convincing or not because we haven't calculated the p-value. Okay, so the t statistic is 3.07. Now, the t statistic and p-value for a two-sided test are what's found in the row for cry count under the corresponding headings. So if we look up here, okay, 3.07, 0.004. But that's for a two-sided test, and because we're looking for a one-sided test, we're just going to divide that by 2. So 0.004 divided by 2 is 0.002 using 36 degrees of freedom. Okay, so that's our p-value. Now, because the p-value of 0.002 is less than our significance level, we reject the null. And we have convincing evidence, the data provide convincing evidence, rather, that the slope beta of the population regression line relating is greater than 0. So we have convincing evidence of a positive linear relationship between cry count and later aptitude score in the population of infants. Now, given the findings of the crying study, should we encourage doctors and parents to let infants cry more to boost their future aptitude scores? Well, definitely not, because since this observational study does show a statistically significant positive linear relationship between crying and aptitude, we can't go ahead and conclude that crying more as an infant directly causes higher aptitude scores. It's possible that infants who cry more are naturally more alert and as a result tend to perform better on aptitude tests. And I'm sure there could be hundreds of other ways that we could explain this relationship rather than determining cause and effect. Now, we used the calculator to calculate or we didn't use the calculator for this specific example, but we can use the TI-84 to perform a significance test for the slope of a population regression line when the raw data were provided. So for the 38 randomly selected infants, here is the raw data of cry count and aptitude score. So to do this, all we need to do is enter the X values into L1, or L1, the cry count values, which corresponds to the X variable, and the score, the aptitude score, into L2, which corresponds to our Y value. Then you go to the stats menu, arrow over to tests, and then arrow down to linear regression t-test. And you're going to put L1 in the X list, L2 in the Y list, frequency, you always leave that as 1. Beta and P, this is a greater than test, so we click greater than. Now, in regression EQ, the regression equation, you don't put anything in there, but if you wanted to, you could put Y1 from the variables menu in there, and what it will do is automatically store the regression equation in the Y equals menu. But you don't have to do that. So we highlight the calculate, press enter, and it takes about 2 screens to present all the information. So only the first screen is shown here because that's all we really need for this problem. But we have the linear regression model, the parameters for beta and P. The T value is 3.06, the P value is 0.002, gives us the degrees of freedom, the A value, the B value, and the value of S, which is the standard deviation of the residuals, not the standard error of the slope. So just be careful about that. But the main thing we wanted here was the T value and the P value. All right, guys, that's it for this section. Hope that was helpful to you. As always, reach out if you have any questions and have a good one.